All right. Now, I'm going to switch up these coils real quick. Yeah, that's why I don't like this one coil. It's very tangled. It's got long ends. All right. This is working with a signal generator today, and I'll show you some other stuff, but we're gonna make sure everything's right down here. All right, I think that's it. Let's put that back in the slot. Let's try that. Keep it like 5 volts, 6 volts. And we're going to put 133.33 hertz in. Yep, we're going up. We are increasing rapidly in the cap bank. I'm not sure you can see the cap bank. Yeah, it's right there. Move this up here. Okay. Well, that's a lot more 20 gauge than the other coil had. It's working differently. So it's barely drawing any amperage, it's drawing 20 milliamps. And we kind of stalled out at like 16.5. Still going up, just real slow. Let's put 12 volts in. And there's a there's an iron powder core in this coil down here. So we're at 25 volts in the cat bank. Hello, hello. We'll get the counter rotator spinning for a second here. 31.6 volts in the cat bank. Wow, dude, that is so cool. It took, yeah, it took a lot to stop it, but I think it's awesome. This is the latest build. We got 2 batteries and 2 drives. I haven't hooked up the pickup coils yet. They're just kind of there to balance the weight. So the drives are 28 and 20 gauge drive with trigger strand of 28. And that's pretty much it, you know. And if you get this in a situation where it can happen, it's going to happen every time, as far as I know. The counter rotation. I wish I could just let her rip, man, because I think she'd remain steady if I didn't touch it. But, you know, I can't stop it currently. I'm working on a flip-flop circuit with the infrared remote, and we're going to try and get it like that. Because this thing has a whole nother part to it that goes on top. Like another cone that'll go on top of it like this. And then maybe the next one will be a little bit more flat on both sides and then kind of push out. But like right here, and then maybe we make this one a little higher and maybe put a glass or not glass, but plexiglass or acrylic so you can see down in there. Be sweet. But you know what I just mentioned, just right up there is 150. Easy. You know, $150 to do what I just said. You need the infrared, you need a flip-flop circuit, you need an SSR. Then you need to reprint this base, make it straight. So that might be for the next print, it might not be. You know, you got to print the top. So, I mean, right there, you're already talking at least $50 in filament. You know, so that's filament alone. But you know, I had some stuff left over from who I was before, and I like dedicated it just to, you know, having some fun, passing the time, and maybe making something cool doing that, you know. Then I bought a house, you know, lots of things. So, but I'm out of money now, so. But I'm loving it, man. I mean, I can't complain. I just can't buy any more stuff right off the bat. Hey, what's up? Thank you. Good morning. Gerald in the house. Man, if I let go of this thing, that would have taken my finger right off, you know, and I know that. Well, maybe not right off, but it would have hurt. Definitely would have hurt. Uh, so yeah, we're looking for an infrared system with a remote. Because we're trying to make it wireless and we're trying to make it simple and fit inside here. We're trying to replace each one of these toggle switches with an infrared SSR, infrared controlled SSR. Yeah, it's yeah, definitely got it has a lot of yeah, I would call that torque. I don't know if this thing will roll up a chain or anything, but or throw on a sledgehammer, but maybe. Uh, all right, so we've stalled out at 36.1 at the 133.33 hertz at 12 volts. And at 12 volts, we're only drawing 140 milliamps off of this coil down here, if you can see that. Right, the gray one. And then this coil up here is 30 and 28 gauge. Lots of it. There's lots of 30 and lots of 28 gauge in there. And I'm hoping will give me a chance to gather more amps. Let's get the amp reader up there. Well, I don't have an amp reader, but I have a multimeter that'll read the amps that are in a situation or, you know, falling through a situation. All right. I'm gonna get you guys off the tripod in a second, so you can see everything a little bit differently. Oh, you're good. You're good. I can see you on my TV. It's on the other side of the room. I'm not reading very well today either, so it's all right. All right. Because I'm not only looking for a break, I'm looking for a power cut. You know, it's not just slowing it down, it's going to cut the power. That's what I want. All right. So let's turn this on to the amp. All right, this says we got 500 and it's going continuously increasing, but we have almost 600 milliamps stored in the cat bank. Almost 700. And that's DC amperage stored in the cat bank. So it's, you know, It's not like a loaded on the line reading of amperage. This is a pool of amps. But we're at 133.33 hertz. I'm gonna change that. I'm gonna level it out. We're gonna go by in intervals of 100. All right. So this is 200. Oh, we're see it goes down. It's going down. See about 300. It's going down rapidly. So I don't even know. There we go. It's going up. 400 going back up. So you catch the sine wave right there. You go up 100, it goes down. You go up further and you go up, keep going up, and then it starts going up again. All right, it stopped. There we go. 500 hertz. 800 milliamps stored in the cat bank and 36 volts. It's increasing at a more rapid rate now than it has in any of the previous hertz. 500 hertz. Anybody got a hertz suggestion they want me to put in the multimeter? Oh yeah, right. I heard the sound. You know, I've heard all different things under the sun. A dead frog or a dying, monkey. I don't even know. They like to relate this thing to animals. Or a diesel engine. I heard that once or a couple times. I like cricket. Sounds. I chirp. It's chirping. And this is just one of the two drives. Just one of the two. So I'm thinking that if the second one ever gets active, I'm not going to be able to stop it. So I'm happy it's kind of chilling. It chirps. It doesn't really ring. It chirps. Like every time it'll pass a magnet, the active coil will chirp. I'm going to get you off there. Maybe you'll be able to hear it. Yeah, chirping means it's working. But on my other build, I had 3 batteries in here, and when I turned the third one on, it would definitely like hum, like consistently. And so I'm like, man, maybe this thing can't handle 3 batteries. But I think there's like a way to put a cap across the transistor to deal with that hum. All right. Yeah, I'll look into getting something a little less expensive. But yeah, it definitely needs that off thing so I don't have to touch it, you know. Yeah, yeah. Well, here, let me show you the bottom of the base. It's a cone-like shape. The cone is the height is 1/2 the length of the base here. So when you put two of them together, you get a square. Oh, off the rotor? Maybe. I mean, I would have to get, I don't even know exactly. Like maybe the positioning's a little wrong. Yeah, this one's really light, so it might just do that. And it offered me to offer you guys a question and answer, frequently asked question or Q&A. We'll try that again later. I don't know how to make that work. All right, there's the amps in the pool. That's pretty awesome, I think. Look at this. 40 milliamps. 58 volts in the cap bank. Wow, oh, look at that. Look, oh, yay. I saw it. You know how like you see the number on the clock or, in your odometer in your car and you're like, yay. It's like, if I don't see this, I'm going to have a bad day. Oh, man. Yeah. Thank you. Should be should be pretty good. Um, I make a lot of different kinds of these things, like counter rotators. I got several of them on my channel at different various points in time. I've done reed switches. I've done trigger coils. I've done external trigger coils. I've done brushes with reed switches and stuff like that. Yeah, I'm kind of like holding it in the hand I normally stop it with. So yeah, that wouldn't end up well for me. I go to like stop it. I'm not probably do it now because I can do it now. I switch to hands. It's a novel idea. Switch the hand you're holding the phone in. Hell yeah, that's what we were talking about on the live stream the other night. That a cap dump could definitely help. Wow, man, my finger. Oh my God, dude, and that's just one drive. That's just one. Wow, I'm like, I could barely stop it right there. It's so powerful, man. I mean, I didn't even expect that. But it is a 20 gauge coil. It's pretty tiny. It's fine. Let me think here. Per circuit is 12 volts. I have two circuits, so that's 12 volts parallel. Yeah. Not currently. Will not fly currently. Thank you. Thank you, Sam. Here, there's somebody, I didn't read that one. Hell yeah. It'll run, the other build, the other rotor that I have will run itself. But it's really lackluster, and running itself, it actually slows down and stops faster than it would without any power. It's pretty much the same thing. It's a coastable effect, because this is how I know. I mean, you got a row of pickup coils, right? Like on each one of these pegs, you have a pickup coil on here, and then in front of it, you have the drive coil. But yeah, I dismantled that one so I could get 2 batteries out of it. It had 4 batteries, and this is the one where, you know, I would turn 2 of them on, and then I turned the third one on, and it just wouldn't work. So I knew something had to like be changed. But this one right here, I can put the top on this, and when I put the top on, and then I spin the shell here. Let me put this back in the other one, because I can get the middle going by spinning the shell. See? When you got the cap on and you spin the thing, this is going to be the thing spinning there, and it's going to get really, really fast, and people are going to be like, what's going on? You know? And then you just explain it to them. There's a motor in the middle that spins it. But it will seriously look like an Utron spinning. It'll be plastic right now, but yeah, the batteries are chargeable. So yeah, I use this right here to charge them. They're lithium ion, so it's not like I'm going to charge the batteries with this machine. That's not going to happen. They'll blow up. I don't have an Arduino, so it's probably not a good idea. All right, so we're stable. I'm going to increase the hertz another 100. Oh, it's going down. So 500 are in the 500s, anywhere from like 450 to 600. I was going to say 550, but you probably get some out of it. It's ringing. The coil down there is ringing right now, but it's still going down. It's in harmonics, I think, some kind of harmonic. Two kilohertz. I was asked to play doctor today, and I think I might have messed up. 3 kilohertz. Man, if I can be up here in the kilohertz and get it to go up, man, that would be great. Four kilohertz. 5 kilohertz. You know, I think I'm going to have to boost the power. That's what the problem is. 8 kilohertz. Let's put it up. Wow, look at that light down there. 40, 45. Was that 45 or so? Still going down. Okay. Going up by kilohertz now. 13 kilohertz. All right, we're going to go. I'm start at 1 now, just to see what's up. Hold on a second. What if one of those magnet files flies off? Oh, you mean on this one? Yeah, well, hey, that's why the duct tape's there. Duct tape is actually pretty strong. I wouldn't, not for how fast I let this thing go. It doesn't, I'm not, without the, turn off the power button, I'm not going to let it go. It's not going to go very fast. I'm going to stop it every time. So I don't even know how fast it would have to be to spit one, but they're glued on and they've got the duct tape on there. And I know that like the walls of this thing actually act as a wind buffer. So I mean it's not as windy in there as you think it is. All these are not glued down. They're just chilling there. And you saw, it go really fast. I'm not really worried about it. But yeah, the final version of this will definitely have lots more consideration. It might be a PCB. It'll be soldered probably, more than likely. But that one coil that I put over here, this coil right here is the best coil I've ever built. It's a 1 millimeter and a 20 gauge. So it's 18 and 20 gauge. It's an awesome coil. It sounds awesome. It is awesome. It's just awesome. And it's like small too. Only like 300 turns. But it's only for drive. I don't care really about the other side of it. I'm getting into it more now than I have before. Maybe not with the counter rotator, but the generator side of things is I'm into making more coils right now with that in mind. Generator stuff. This rotor right here is one of my first ones I ever made, and I've been doing this for 3 years. It's 9 magnets. It's like the best that I've made. It'll spin for 25 minutes after you turn it off. Hell yeah. Hello. How's it going? All right. Put 5. Put 15 in. Hello. All right. Now, see, look at it. Doesn't that look like it's picked up speed? It's amazing. I love that thing. It's awesome. So with the 10 volts in at 50 or 10 hertz in at 15 volts and 600 milliamps, we are slowly generating. Let's turn it up a little bit more. 12 hertz. It's actually going up faster just by putting 2 hertz in there, and that's awesome. 15 hertz. 5 amplification. So we got 16, 17 volts in the cap bank. We're coming up on, yeah, oh, skipped right over it. Ah, going so fast, going up so fast. All right, so, God, I got the circuit like drawn up somewhere. But it's simple. You got your base connection, and then you got a light. So you have one connection for the light in the collector and one connection for the light in the emitter. So that's 1, and then 2 goes to the collector to connect to the battery or to the end of the coil. And then the emitter has 3. The light, the ground for the trigger coil, and the ground for the circuit. And that's pretty much it, man. You can use your own imagination after that. That's what this is. You got your light. The light is pretty much the only kind of resistance in there at all. Oh man, it's still going. 19 volts in the cap bank, 409. All right, I'm gonna put the camera back on the thing, and then I'm gonna change where this meter is connected. I'm gonna connect it to straight to the coil so we can get a sine wave. So I still get the voltage reading off the cap bank, but I want to get the AC reading off the coil. No, I think it's the other way around. Positive end goes on 30 gauge because it's in the center. Right? Alrighty. Let's turn around and see what we get. Oh yeah, we want to put that. We want to hit this. Yeah, I think it is what you would call ringing. I don't know if that's right, but we'll check it out. Yeah, that's pretty sweet. That's 27 hertz in, 13 volts. And put it back to 133.33. Look at that. Look what happened. Wow. That's 133.33. That's 33. 233. Wow. Wow. Okay, we got M's now. That's how much amperage is being drawn. Now you see the difference? Maybe. That's awesome. So this one is the best gen right here. This is the best gen right here so far. That's 233.33. Wow, that didn't want to stop. I love it though. It's so awesome. It's like, feels powerful even. Just moving, like seriously, I couldn't make it go any slower. It was amazing. A balanced motor, yeah, I agree. Don't know what to do there, Joe. Man, if you can't help me, it's like 107. I can't read it. Hold up. Wiping the lenses. See if that'll help. I think it's like 104. Hello, hello. So we're got a 104 volt sine wave off of 13 and a 70 millivolts and 233.33 hertz. It's awesome. Let's see what happens if we put some, like up to 250. Oh, it went down. It went down. Okay, we're not going to do that then. I'm going to set it up for the... There it goes. Look at that. That's awesome. But it's not very strong. There we go. There we go. 55. You going up? Oh, looks like we're going up. Cool. So steady increase at 55 hertz. Heck yeah. I wonder what's wrong with the second one, because I don't know, sometimes if it's like connected, it will turn into a permanent magnet. I don't like that. It means the transistor's blown, and I know that, but it's like, then I change the transistor and then turn it on again and nothing happens. So I gotta find out what's going on in there. Yeah. Let's see, the permanent magnets are facing south inward. So you know what I'm going to do? I'm going to flip them. I'm going to flip them all facing north inward and see what happens. It should be the same or different. I don't know. The batteries inside of the rotor are very magnetic. I might have screwed that up. Oh, got it. All right. That's pretty good too. All right, I got another one. Let's take, make it a 120-degree circuit. Of the north. All right. Now I'm going to cut this. That's pretty smooth. See, that's not shaking at all yet. There it goes. I'll have to find all that stuff. So yeah, PCB board is definitely where we want to be. Yeah, I'm gonna have to find all those pieces. Well, maybe not, actually. Sweet. All right. Well, that's on hiatus right now. But you know, I've put them together so many times that this is not a big issue. I'm just glad it didn't like break anything. It was a breadboard. It wasn't going to break me. All right. So I'm thinking, actually, you know, I'm thinking that I'm going to set this up here. I'm going to get my magical coil. And I will be right back. Let me look under there. Yep. Okay. Glad you're okay.
Thank you. Bye.
Bye. Hold on. Say goodbye. Bye.
I got her, I went to Moira and got her some like shampoo and conditioner. And what you need because she's got a dry head. And then I Googled something and when I went to Moira and looked at the shampoo for that, there was something called
No. All right. So I need a clip. Wow, that was exhilarating. Nobody got hurt. That was the first time I've had that happen with one of these, actually. That's why I wasn't like. You know what? I'm not going to do that. It just came a little late. All right. Oh, yeah, that's right. Yeah, that 32 is nice and tiny. All right, there we go. And look around. But the ironic part is that it wasn't the duct taped part that broke. The part that wasn't duct taped that broke. So I'm gonna double down. All right. Tiggs, get down. Tiggs, get down. All right, I guess we're done for right now. That's a blown transistor. Maybe, yeah. Man, I'm so like, come on, man. Just found the problem. I hope it's not really blown. Look out, Tiggs. Tiggs, baby. Baby Tiggs. My cat. There it goes. Okay, I found one. Thanks, Daniel. Yeah. Look at that, man. That coil just pumps. And I think it's because the neos are huge. That thing weighs a ton, you know. You know, 3.5 volts to 20 milliamps. Look at that baby fly. That's great. So, yeah, it's been great. This is awesome. Even though my counter rotator isn't working right now, we're gonna get it back. We're gonna get it working, and that was awesome, man. It was going super duper when it broke, man. But it's super duper fast. But this now, I love playing with this one too. That's awesome. So, but I'm gonna have to get some more transistors. I'm gonna have to incorporate a PCB board, obviously, with some solder. That'll be awesome. So whoever said that it was going to spin apart, a few people said that. Absolutely, is without the things being cemented in, they're gonna fly away. What is what for? This one? You tell me. I don't know what it's for really. It's there's no like end result that is really linked to outside of itself right now. Fuck yeah. Yo. Mm-hmm. Could definitely do that. It's gonna wind up on the pole though. Mm. All your ideas are very practical, thank you, but no. Cat, it's the Spankatron 9000. So you instead of hooking a cat toy up to it, you pick a big rubber hand attachment and just except like umpteen faster, you know? Yeah. I know. I thought about the cat toy, but I'm like, nah. But seriously, it's going to be called OneDrive because it runs on OneDrive. I try to put more drives in there, but it just doesn't happen. So it's gonna be called OneDrive with the number one. I don't know, just an idea. All right, as long as I can do that and have it fit inside there, we're good. Absolutely, I would definitely consider it. It doesn't need to spin that much faster though until it's completed, like with the PCB board on it. Like just that fast, it spun apart. All right, we're gonna go up to 6 volts. So the next iteration, it's got to have. Yeah, we're not gonna go 2 for 1 here. I love it, man. It just spins, and now we're gonna let it spin, and man, because this is the balanced rotor, man. This is flat. It's light, and the weight is distributed perfectly. All right, take it easy. Mm. Yeah, I can't see where the other breadboard went, but I know it's around here somewhere. Mm. Yes. And I want to play with it, but I can't play with it until I put it back together. So cool. And then normally I run this one with this one. This one's really good. It's hooked up to a Litz wire coil. And that's the last one in my 3 friends experiment. So we have a pulse motor here, we have a pulse motor here, and we have this one here, and the energy goes through all 3 of them. Of course, you're spending energy to run 3 pulse motors, but with it being jostled around at a frequency like that, your cap bank or your battery may receive more energy than you put in, because it's a different kind of energy. And when you apply frequency to what you're doing, you could get a more rapid charge on your cap bank than just not doing that, and then having more than one frequency. And that's what I'm testing. It's not more actual volts and amps, because that's not possible. It's just a different frequency, which will then in turn give you more energy in the cap bank faster. And yes, it will. Does it mean you got more energy than what you put in? No, it just means you're utilizing, and the frequency is a really tricky. Yeah, it's just different. And with this stuff, you want to be down in the 200, 250, 150 range. You don't want to be all up in the kilohertz with your pulse motors. You're not going to get, well, I haven't gotten anything off of that. Maybe one time a while ago, I had 85 kilohertz and I was charging, but it was like a lackluster charge, and but it was 85 kilohertz. So yeah, I guess you can find a charge frequency like at a really high rate, and when you do that, you're like charging no milliamps whatsoever, like barely any. Now, the other rotor that I had for this thing had pickup coils on it. See, these are drive coils. There was pickup coil and a drive coil. And so when you spin it really fast, you get the magnetic induction. And I had 2 of these cap banks on there too, like right on top. Bam, just right up on there. I have a video out it's a short video called Fast, Fast, Fast. And you'll see that the cap bank is up on top. And all the pickup coils are linked in series and connected to the cap bank. So when you spin it, you get energy out of air, out of the magnetism. That isn't completely, it has nothing to do with your battery. Nothing. You will get more energy out of the pickup system if you use the battery, though. See, because the pickup coil is behind the drive coil. So when the drive coil hits, it's going to send a surge of energy to the pickup system out of proximity. So what we were just doing over here with the signal generator and generating power, that's what we were doing. We were doing it on a proximity transformer, generating energy through proximity. So I don't know exactly how much it would generate, but the cap bank would get energy way more rapidly. And then the energy that goes in the cap bank was connected directly to another drive coil and another transistor. So it would flow straight through, And as long as it was moving, it would move under the power. But as long, it doesn't, it's not, and yes, it will. Yes, it will. It will run itself, but it'll end up being slower and less farther than if you just let it coast. And that's a fact. It is so much like unbelievably a fact that I'm like so tired of people telling me, no, 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 no. I'm like, yeah, come over here, stand by me, and then tell me no. Because I'm not listening unless you know it, you've seen it and you know. If you read it in a book somewhere, I'm not listening. Now, will it stop? Absolutely. Is it supposed to stop? Yeah. Where did all that energy that is supposed to go into the cap bank go? Where did it go? It went into perpetuating motion. And then when you, and that's the wrong word because it's not going to last forever, but it increases the amount of motion. There you go. But I always found those two words to be kind of synonymous, like kind of the same thing. So when people trip when I say the one or the other, it's like, oh my God, dude, really? So let's look at this. The power's off, right? Look at this. See how it's creeping back up? That's the benefit of having a 9-magnet neodymium rotor that weighs a ton. It's still going down, but every like third one, it'll creep up 5. A flux capacitor? No. Uh, it's a counter-rotating DC brushless motor in the shape of a neutron. It was automated, but I broke it like an hour ago. But I'll put it back together for the next one for sure. And we'll have a blast. I'll tape it all down next time. Wow. Yeah, I don't do math. I feel really bad for people to get involved with that stuff. So, I mean, yeah, if you're going to mention it, you're gone for good. That's awesome. And that's on. That'll spin. There's no milliamps being drawn for that. It's 2 volts. If it's what it is less than 10 milliamps. You can hear it like chirping, literally like a cricket. Thank you very much, ladies and gentlemen. I'll be back later. I'll fix this up and we'll get it going. All right. Peace out. Have a wonderful day. Bye now. No. No, it's a counter-rotating DC brushless motor. What it's gonna do in the long run, I don't know yet. So I don't even have a schematic for it yet. So yeah, there's none of that stuff floating around yet. All right, peace out.